Hi! Sorry, we have no furniture. This is my final presentation for Intro to Behavior Analysis for my second assignment. And I did my project on evaluating the effects of a technology-based receptive IT program and compared to the same program being taught in a discrete trial setting and its effect on rate of skill acquisition in young children with autism. So I took a look at computer automated reinforcement, which I saw that they were characterized by automatic data collection and the delivery of reinforcement without human intervention. Crenshaw et al. Talked about his automated apparatus to deliver reinforcement and take data on to condition a free operant in octopi. Ball and McCready had a transistor radio to help improve posture, and Lynch et al. Had the self-injurious behavior inhibitor system, which produces electrical shock automatically. I looked at some of the benefits. There's the consistent immediacy of reinforcement, which is sometimes difficult when it's run by a human experimenter. Cooper et al. Emphasized how important this is, that the behavior temporarily closest to the presentation of the reinforcement will be strengthened by its presentation. And Sidman said, to underscore this, that a response to reinforcement delay of 1 second will be less effective than a 0-second delay. Some of the drawbacks to something like a computerized intervention is that it takes out human interaction and the opportunity for social praise from adults, which Sugawara et al. Found that adult social praise accelerates motor skills performance by enhancing motivation, so it can be very beneficial when teaching a skill. So we had 4 participants. They were all between 2 and 3 years old. They previously mastered sitting at a table and attending for 10 minutes without interfering behaviors. They were familiar with a touch procedure either through body identification or use some other receptive ID program or family ID program. They had to have an understanding of the first sign contingency. So the dependent variable was the number of sessions that it took to meet the criteria for mastery for a particular set of targets. The independent variable was the modality or the intervention used in which the receptive ID program was taught. So whether they were taught in a discrete trial setting or whether it was the computer-based program. Mastery of targets was defined as 80% independence over 3 teaching sessions for those targets. And in the final phase, where all the targets were put together in a random rotation, it had to be 90% or better over 4 teaching sessions. And so this was the file output for data collection taken by the computer program. So it had the name of the trial, how many, if there were consecutive errors, how many errors were made for that particular trial, and the response latency for that selection. And a paper and pencil method was used to score the responses in intervention A. I used an alternating treatment design. Basically, in the first phase, I divided up the participants into 2 groups. They were randomly assigned. Jack and Emily received intervention A, which was the discrete trial, the traditional discrete trial method. Ben and John got the computer program method, and they were all in that condition until they each individually mastered those targets. Once those targets were mastered, they moved on into the next phase, into phase 1B, where they went into the opposite condition and had a new set of targets, and it alternated back and forth like that until all 20 were introduced. And then in the final phase, for phase 3, A and B, again it was alternated over 2 sessions each, and it was until mastery. Procedure, so first there was baseline data taken. Each session had 10 trials. The first 5 targets were taught at a time. In the final phase, again, there were all 20 targets in a random rotation. One phase was described as intervention A with 5 targets, and intervention B with 5 additional targets, and you can move between the phases until they were considered mastered as identified in the criteria. 2 experimenters alternated working with the 2 participants at a time individually in each each phase. So every phase they would switch to ensure that each child was working with each experimenter. Get up into, here's the program. So this is just the default screen. So you click on the middle box, and then you have to touch the correct one. If you touch the correct one, you get access, or the learner gets access to a 20-second video. In this case, it was Elmo. And I'll just skip over that. And again, this goes through until all 10 trials are complete. So I just want to show you what happens if the child makes a mistake. Say it says touch strawberry, and they touch orange instead. They have to stare at a blank screen for, it looks like it was actually a little bit shorter. It's supposed to be 5 seconds. And it reappears with the correct answer highlighted in green, and the yes deltas are highlighted in red. If you choose the wrong one again, again the screen goes blank. I tried to make it as not fun as possible. So again, it goes back to the video for 20 seconds. And they were divided up into 20-second chunks, and it loops. There's a few videos that loop around. So that way it's being controlled very tightly. Right now I have 20 targets uploaded in here to simulate as if it was the final phase of treatment. I didn't want to just have 5 at a time. I wanted to be able to show how they all randomly rotated. We haven't been able to get rid of these other 2 pictures on the side. Ideally, what would happen is the icon that says I earned a break would come up, and the child would know that the session was complete. There was supposed to be, after 5 seconds of no response, there's supposed to be, if the child made an error, the correct answer would be outlined in green, and the 2 incorrect answers would be outlined in red. But something went wrong with it, and I don't know why it's not appearing on there, so I'm sorry about that. So for the results, I noticed there was a downward trend in the number of errors per phase across participants and phases, and that could have been maturation. It could have been them becoming familiar with the procedure, because it could be unfamiliar in the way that the experimenters taught it. But it was observed that there was an up and down trend between each phase, and it was a main effect. So 2 kiddos in the intervention A generally had a higher number of errors, which went back down again when they went into intervention B. And as we had 2 pairs of individuals in each condition at the same time, there was a lot of crisscrossing going on. We noticed that the average number of errors declined overall. It started off with almost 48 errors total in phase 1A an average to just over 10. So for Jack, he actually was able to learn the skill in 4 less teaching sessions for the targets that were taught during that intervention than in intervention A. So he did seem to acquire the targets that were taught in intervention B quicker. I found a similar result in Emily, who generally had less errors overall, and she seems to have a faster rate of skill acquisition in general. Her results were much more dramatic in that she had 7 fewer total teaching sessions required to meet the criteria for mastery in the targets that were taught in intervention B than the ones that were taught in intervention A. Ben had he had a higher rate of errors and seemed to have a slower rate of acquisition. There was less of an effect, but there was still an effect of 2 less phases required to meet the criteria for mastery in intervention B. There's a similar situation with John. So in conclusion, there was some preliminary data gathered that technology-based teaching could increase the rate of skill acquisition over traditional discrete trial training. Learners with a higher rate of skill acquisition overall and fewer errors seem to have a greater benefit between these 2 conditions. There's less of a benefit for participants with higher errors and a slower overall rate of acquisition compared to their peers that generally seem to acquire skills quicker. And more research is needed to examine the relative rates of success across different learners and different programs and what variables affect these outcomes. Thanks so much.